Quantitative Data Analysis Techniques 4.5.1 Data Preparation. There are four ways to prepare data: through range, rank order distribution, single frequency distribution, or grouped frequency distribution. Range is the difference between the minimum and the maximum. For standing vertical jump, the maximum score was 56 and the minimum was 15. Therefore, the range is 41, as you would subtract 15 from 56. The higher the range, the further the values are spread apart, which shows how significant difference is between the maximum and the minimum. For standing vertical jump, the range shows the difference in abilities for leg power. If the range for standing vertical jump was very high, then it would show that the abilities in the group of people vary a lot. Rank order distribution is when you put a set of numbers into size order, starting from the largest and finishing with the smallest. This allows you to see who got the best scores and worst scores, the highest and lowest populations, the highest and lowest costs, and many other things that can be put into order. For the standing vertical jump scores, I put them in rank order from best to worst, which helps me see the participants with the highest and lowest abilities. This method of data preparation can also help me see patterns, which help me think of reasons why certain people, places, or things have better or higher scores than others. Simple frequency distribution is used to see what scores people got and how many people achieved each score. As shown in the table, the scores are all shown in the first column, followed by tallies showing how many people got each score. The frequency column then shows the number of people who got each score, and then the cumulative frequency is worked out by adding the frequencies together to show how many people or things participated. This is a good method to use, as it clearly displays the data so that the researcher can see what scores the participants got, and it tells you which score was the most and least popular. This allows you to find theories to explain why a lot of people got the same or similar scores, and it also shows if someone is a lot better than others, as they were the only one to get a certain score. Group frequency distribution is very similar to simple frequency distribution, as they both show the number of people who got the same scores. However, group frequency distribution presents the scores in groups so that participants could get different but similar scores, and they would be put into the same category. The table here shows that 2 people got a score between 10 and 19 for the standing vertical jump. I can also see that 5 people got scores between 40 and 49, which shows that it is the mode, which can be very useful for analysing the data. However, a bad thing about this method is that it doesn't give it exact results, which isn't good because 49 and 40 are in the same group, even though 39 is closer to 40. This means that it doesn't quite make sense, as someone could look a lot worse than someone else even though their scores are one number apart. On the other hand, it does show the data quite clearly, and it helps to show the different abilities in the group of participants by putting them into subgroups. Quantitative Data Analysis Techniques 4.5.2 Presenting Data. Scatter graphs are one method of presenting quantitative data, and they are used to show the correlation between two different factors. In other words, they are used to see if one factor has an effect on the other. Each dot on a scatter graph represents a person's results from two different measurements. In my example, I tried to see the correlation between thigh girth and results for standing vertical jump. However, the results show no correlation, which could be because the thigh girth could be larger due to more fat, which would make the standing vertical jump lower as there's less muscle. A positive correlation would show a diagonal line gradually getting steeper, and a negative correlation would show a diagonal line going downwards, as shown in the diagram. Line graphs are another way of presenting quantitative data, and they can be used to compare results from two different tests. In my case, I used results from a static sprint test and a flying sprint test and created a line graph to show the two results of each participant. The standard deviation bars show the mean of each set of results. If there is a large overlap, then it means that it is less likely that there is a significant difference between the data. As the lines do not overlap that much in my line graph, it suggests that the mean of the two data sets are different, and it is more likely that there is a significant difference. In my data, one of the results for static sprint was over 7 seconds, which shows that it is an outlier and can be disregarded as it is different from the majority of the data set. Tables are a very simple way of presenting data. Tables have headings above each column which tells you what the data is and what is measured in. The rows are used to present the participant score in each test they completed, and once all the participants' data is gathered, you can work out the mean, mode, median, range, maximum, and minimum. Tables are very clear and easy to use, but you are able to create other graphs and charts with the information gained from the table. Another way of presenting data is by using a bar chart. Each bar represents participant score, and the y-axis shows what the measurements go up in. Bar charts are very clear as you are able to see the differences and similarities in the results very easily, as you just have to look at the height of each bar. Bar charts are also good for finding outliers, which are results that are significantly different from the others. I used some fly and sprint test results from a group of participants and put it into a bar chart. I can now see all of the participants' results in a clear format, and I am able to see which participants are better and worse. I could then try and work out why some participants got lower scores and if there were any variables that were different for each person. Box plot and whiskers. These are another method of presenting numerical data. The two lines at either end show the minimum and maximum, and the box shows the interquartile range. The interquartile range is the middle 50% of the data, and the line in the center of the box is the median. The longer the whiskers are, the bigger the range, which means there is a larger difference between the minimum and maximum. If the box is long, then it means that the interquartile range is spread apart and the numbers aren't that similar. Box plot and whiskers aren't very clear methods of presenting data, as it can be hard to see the exact measurements. Also, most of the data is grouped into the interquartile range, so you have no idea what the numbers are and if there are any patterns or significant variations. Finally, histograms are another way of presenting quantitative data. Histograms are similar to bar charts, as they both use bars to show the participants' results. However, histograms are different, as they put the results into different but even groups called buckets, which can be as large or as small as you want, but it is better to have more than 4 or 5, as it shows the difference a lot better. In my example, the buckets have a range of 50 centimeters, and the bar's height will then show the amount of participants in each group. The buckets do not overlap and the data is continuous, so there are no gaps between the bars. When using histograms, you would not usually use a normal distribution curve to see if your data is normally distributed. A normal distribution curve shows how equally your data is distributed. In normal distribution curves, 95% of the data is between -2 and 2, and 68% is between -1 and 1. This 68% of data is known as the standard deviation, which is the data that is either side of the mean. The wider the curve, the larger the standard deviation, and vice versa, as the data either side of the mean will be more dispersed. If the curve is thinner, then it means the results are more precise, as there is less deviation and variance. If data is evenly split either side of the mean, then it will give you a bell-shaped curve and the data is normally distributed. However, data can be negatively and positively skewed, which means that there can be more data on one side of the mean. A negative skew is when the long tail goes to the left, and a positive skew is when the long tail goes to the right. This would be a positive skew, as you can see that the bar on the far right is too high for the data to be normally distributed. There is also an outlier, as the bar on the far left shows very different results to everyone else, so this would normally be disregarded as it goes against other results. Removing outliers on a set of data is known as trimming, and was created by Hawkins in 1990. Another method used to deal with outliers is Wins Horizon, which is when the outlier is changed to the nearest acceptable value in the set of data. If data is normally distributed, you would use a parametric test, but if it is skewed, then you would use a non-parametric test. Descriptive statistics. Descriptive statistics is the measure of central tendency and variability. Measures of central tendency are the numbers that describe what is average or typical of the distribution. Adams et al. 2010. Measures of central tendency include working out the mean, mode, and median. These are single numbers that represent the dataset in different ways. Measures of variability link to the standard deviation range and interquartile range of a set of data. The mean is the measure of central tendency that is calculated by adding all of the values and dividing the answer by the number of values. For standard vertical jump, the sum of the results was 518 and there were 14 participants. If you divide 14 from 518, it gives you 37, which is the mean for this set of data. This gives you the average score for a set of data but does not take outliers into consideration, so the mean may not be an accurate representation of the set of data. This is why the mean should only be worked out after the outliers have been Winsorized or trimmed from the data. Finding the mean is a good way to see the average ability of a group of people, and it is used to find the standard deviation, which shows how dispersed your data is. The mean may not always work for certain sets of data, as if you've worked out the mean for the amount of participants, it may give you an answer like 4.3, which doesn't make sense as you can't have 0.3 of a person. According to Adams et al. 2010, the median is the middle value in a series of ordered numbers. If there is an odd number of results, you would use the formula n plus 1 divided by 2 to find the position of the median when n equals the number of results in the data set. If there is an even number of results, then you would add the two middle values together and then divide the value by 2. In my set of results for standard vertical jump, there is an even amount of values, so I took the middle values, which were 43, and multiplied them together to get 86. I then divided 86 by 2 to get 43, which is the median. The median is less affected by outliers than the mean. This is because you're only looking for the middle value, which will give you more of a reliable average score, as the middle value won't change even if there are anomalies in the data. The median can only be used with ordinal data because if the data isn't ordered, the middle value could potentially be the smallest or largest result, so it doesn't represent the middle value of the data. If there is a large data set, then it can take very long to work out the median, and if the data is too small, the median may not represent the results realistically. Adams et al. States that the mode is the value that occurs most frequently. The mode in my set of data is 43 as it occurs 3 times, which is more than any of the other values. Mode can be seen graphically when data is put into a frequency graph like a histogram. This means it doesn't take long to find the mode if it is presented in a clear frequency graph. Also, the mode can be used for nominal data whereas the mean and median cannot. However, the date may be bimodal, which means that there is more than one number that can occur more frequently. In continuous data, there is less chance of there being a mode, so it cannot always be used for all types of numerical data. Standard deviation is a number that tells you how much the data deviates from the mean. This shows how similar or spread out the results are, which can be used in analysis as it can tell you a lot about the variation in the group of participants. To work out the standard deviation for a set of data, you first need to find the mean. In my set of results, the mean was 8.21, and you then take this number away from each of the results, as shown in column 3. The formula then requires us to square each of the values that we have gained from subtracting the mean from the results, and the squared numbers are then added together. Squaring a number means multiplying it by itself. Once you have added the square numbers up, you need to put it into the formula, which is the square root of the sum of the mean subtracted from each result squared divided by the number of values minus 1. There are 14 values, so 14 minus 1 is 13, which means the formula is the square root of 112.3 divided by 13, which tells us the standard deviation is 2.94. If the normal distribution curve is wide, it means the data is spread apart and the standard deviation is higher. If the curve is narrower, it means the data is similar and the standard deviation is lower. If the values in the data are closer to the mean, it normally suggests that there is more precision and the mean is more representative of the data set. The standard deviation will be close to 0 if the values are close to the mean, but it will be far from 0 the further away they are from the mean. A limitation of standard deviation is that it can be hard to calculate manually and can take quite a long time. This is why it's better to calculate it on Excel, as it works out most of the problem for you. The standard deviation is useful for theoretical work because it has a real meaning, as it can tell you a lot about the group of participants that were used.